Well, good day, everybody. My name is Mike Beam, CIB's Program Director, and I want to welcome everyone to this event. This is CIB's second ever Best Doctoral Research Award competition, and we're really excited to have a great group here. We're really excited to have you here to listen to these. We had a great inaugural Best Doctoral Research award competition last year. And I really want to thank CIB's board for thinking that this is a good initiative to continue this. And I believe we're going to continue this into the future. So I want to introduce some of the judges very quickly. Kathy Michelle. Hello, Kathy. Good day. Kathy is the Deputy Dean of Built Environment and Engineering at the University of Cape Town and is a current board member. Our award winner last year is with us. We're really thankful to have him. Ishmael Eftekarian is a Senior Research Associate in the School of Mechanical and Manufacturing Engineering at the University of New South Wales. Ishmael, thank you so much for joining us. Anita Teriek comes to us from AMI, the Hungarian Institute for Construction Research, where she's a senior researcher, and she's also holds a position at the Technical University in Budapest. Anita, thank you for joining us. Good day. And Billy Hare is a professor at Glasgow Caledonian University. He is also another award winner. He won the Wim Bakken's Best Coordinator Award this past year at our World Building Congress at RMIT. And I also want to thank Srinath Pereira, who leads our Future Leaders Network. Many of you know Srinath. He works tirelessly. He's a volunteer, he's a board member, and he does some great work in just organizing all of these early career researcher and student award competitions. So I really want to thank Srinath, and I know Srinath could not be with us today. And now what you've all been waiting for are the candidates. We have three outstanding doctoral researchers who are going to present in 8 minutes today. We're only giving them 8 minutes to present, and we talked about that, and we're going to introduce them very, very briefly here. Ann Lee, first of all, good day, Ann. Ann is currently a postdoctoral fellow at the School of Built Environment at Massey University. She has a bachelor's degree in quantity surveying, master's degree in construction management from Hanoi University of Civil Engineering. She was a lecturer there for more than 4 years before pursuing her PhD at Massey University. Chengyang Liu,
Hello, everyone.
Completed his doctoral degree at the School of Property, Construction, and Project Management at RMIT University. His doctoral thesis investigated the virtual power plant's impact on distributed renewable resource management and urban sustainable decision-making. He's currently a research assistant at the Solar Energy Lab at RMIT. And Navodana Rodrigo, good day. Navo is a lecturer at the University of Adelaide in Australia. She completed her PhD from the Centre for Smart and Modern Construction at Western Sydney University in Australia. Prior to that, Navo completed her bachelor's degree in quantity surveying with first class from the University of Moratuwa in Sri Lanka. So we want to welcome all of our judges and our three incredible doctoral research award candidates. And we're going to go in order. I'm giving them 8 minutes, and I'm going to ask Ann Lee to go first. And I'm going to have my timer on, Ann Lee. And if you can go first, and and Ann Lee, if you can let me know that you can still see me in my famous red flag, which I'm going to give you at 7 minutes. So yeah.
Yes.
And I think you stopped sharing there for a second. Or you stopped sharing there,
okay.
Ann Lee,
yep.
And now it's back. Yeah.
Can you see my screen now?
We sure can. Thank you so much. We are ready when you are.
Yes. Kia ora, hello everyone. Thank you for giving me this opportunity, and it's my pleasure to be here to present my PhD work to you all. First of all, why did I select the topic for my PhD? You may know that to build a building, it might take only a few years, but the building needs to be well maintained in over 50 years or longer to be functioning properly. And school buildings are not exemption. In New Zealand, there are more than 2,000 schools, and yearly around 1 billion are invested in managing, improving, upgrading, or innovating the school buildings. However, we still can see some problem due to the poor condition of the school building. For example, the damp and moldy classroom in several regions in New Zealand, or like the disrepair building, or the building they don't provide a safe and healthy environment for staff and students. So the question raised, how to manage the school building effectively? From the literature review, I found that strategy, principle, guideline, or standard are already there. However, they mainly focus on what you must have to comply with these standards. The part of how to achieve them still missing. So I attend some training course of the property management in New Zealand. I talk to property people in New Zealand to understand what the current model look like. So the current model have the planning and implementation stage. However, managing the school building here in New Zealand is still challenging due to the fragmented process, and many people who involved in the process, including the Ministry of Education, external consultant, and school board, with their diversity of ideas, expectation, and ability. And still we don't know how well they work together. So the research question will identify, including what are challenges in managing school buildings, how well people involved in the process work together, how the maturity level of the current model, and how to develop a framework that can support the stakeholder in managing school building effectively. So the overall research aim was identified to develop a framework that can solve the current issue and at the same time can improve the team collaboration to achieve the higher maturity level in managing school building in New Zealand. 4 research objectives has been established. So apart from the literature review objective, the 3 objectives try to answer the research question. So I won't repeat it here. And this is an overview of the research design with different phases, with different techniques and different methods for my data collection to help me to answer the research question to achieve the research objective. The key finding of the research, what are challenges of the current model? So the challenges are identified, including lack of a shared vision among the key stakeholders involved in the process, imbalance of resources, especially for small schools in rural area, lack of capability because the school people are not property people. And also currently we have a data management system, but at national level, not at school level. And also no performance evaluation. The questionnaire survey allow me to examine the relationship of the people who involved in the process using the partial least square structural equation modeling. And the result proved that there is undeniable relationship among the key stakeholders. They have both direct and indirect effect on each other's performance. So therefore, they need to work closely as a team in order to improve the managing school property process. According to the result, I developed a new framework based on the current model. So if you remember, the current model have plan and implementation of the capital project. I added the established, maintenance, evaluate, and improve stage in the current model. I further developed the model using the integrated defined functioning approach. So that helps the stakeholder to visualize where they are, who they work with, what are the input, what are the expected output, what or who controls the activity. So for every single activity in the framework will be visualized like this. Along with the diagram, I also identify the challenge and action or risks associated with activity. So people don't need to add all activity. They can choose to add the activity based on their current situation, based on their challenge or the action or the risk associated with the activity. Here are the research contributions. So for the first time, my research used a combination of maturity model concept, plan, do, check, act, cycle, and IDEF thereof to develop a framework for improving collaboration of stakeholders in the built environment. So what are research contributions to practice? You can see on screen the 6 objectives of well-managed school poverty by 2030, published by the Ministry of Education in New Zealand. So my research, my framework can help to address 5 objectives or 6 objectives. You can see some highlighted keywords on the screen. So the research framework already clearly defines the roles and responsibility of people who involved in the process. It provides training. It helps to improve the accountability, help to collect the data, and at the same time can help the school board and principal in managing their school building. And here are some examples of the comments that I got from the school principal during my evaluation. So they said that it's clear to understand and it's straightforward for the new principal who joined the process. Another said that the process is transparent, so people know what's happening and who got responsibility, and therefore they are all on the same page. And another comment about the evaluation, because evaluation is not currently happening. So it is a key improvement of the framework. Here's a list of publications as the outcome of my research work. Some was published in the journal paper, some reported in a conference, and some still under development. Thank you for your attention.
Thank you, Anne. 7 minutes and 20 seconds. I really appreciate that. That was excellent timing. Thank you so much. And if you could unshare the screen, that would be great. I told the judges we could have 1 question. I don't see a question coming in, so we're going to move on to Chengyang and his presentation.
Michael?
Yes.
Let me share my screen.
Wonderful.
All right, can you all see my screen right now?
Yes. Thank you so much. Thank you so much. Begin when you are ready.
Thank you, Michael. Good morning, good afternoon, and good evening, everyone. My name is Chengyang, and you can also call me Gavin. Today, I want to share with you about my PhD research in improving distributed renewable energy performance and urban sustainability with virtual power plant. So to begin with, let's have a look at this diagram from the Australian National Electricity Market. The wholesale electricity price is deemed to increase by 50% in the next 2 or 3 years. I'm not very sure about the demographic profile of our audience today, but I think there are similar situations globally because of the increasing fuel price, limited network capacity, and increasing demand due to the climate change. And all this will significantly increase the living costs for many households and also communities. So one of the solutions to that is to enable the maximum capability of distributed renewable resources through virtual power plants, or VPP. A VPP is essentially an Internet of Energy, or what we call a smart energy management system. It centrally manages the decentralized generators such as rooftop solar panels and batteries in a broader area, typically within a community, to maximize their capacity and benefit as one generator. But before we give too much credit to VPP, let's have a look at the problems and the challenges with it. So in the beginning of my research, we conducted the Centrometric literature review, and shown on this screen is the keyword network of more than 1,400 publications in the domain of VPP. Using this method, we identified 3 main challenges involved with VPP, namely suitability, techno-economic uncertainties, and future-proofing. And we have also validated these challenges during our talk with many stakeholders. For example, the Solar Victoria, who is actively promoting a VPP project in Victoria, and to them, one of the main challenges is also to identify the suitable participating communities, considering their demand and supply condition and socioeconomic status. And there are also other questions among the stakeholders, such as to what extent can VPP operate without fossil fuel, and can it support our future demand and future renewable energy growth? So in light of these questions, in this research, we aim to use the concept of virtual power plant to support the decision-making in renewable energy management and urban sustainability across communities. And we propose the 4 objectives, namely establishing the conceptual framework, modeling out and optimizing the VPP's performance, and evaluating the VPP's impact. Let's have a quick look of the research design. We carried out a case study in the city of Greater Bendigo in the center of Victoria. This case study covers 235 local communities defined using the statistical area level 1, SA1. We have a multidisciplinary research background because to understand the VPP's performance in different communities, we need to carry out optimization, simulation, and analysis for all the 235 communities. And this will require a large amount of data and proper data analysis tool for that. So we utilize the geospatial data science, machine learning, socioeconomic analysis for this research. And we also receive a lot of data support from our research partner and funding bodies, including the City Council of Greater Bendigo, Victorian State Government, Center for New Energy Technologies, and PowerCo. Now let's have a further look of our research process. So on this screen, it shows the geospatial analysis result and the simulation, including solar potential mapping, shading simulation, rooftop solar panel image recognition, and angular parameter analysis. The purpose of this process is to capture the urban environment dynamics for the case study area, and we mainly focus on 2 aspects: establish the urban dynamic profiles for each community and to understand existing and potential renewable resources in the case study city. And to manage and also operate the VPP in the communities, we adopted reinforcement learning for the system modeling and control. The reinforcement learning is a highly efficient approach to provide robust optimization against large amount of uncertainties and diverse environments. Honestly, it's also one of the most complex methods you can use in machine learning domain. A simple explanation for that is that it mimics human brain's learning process. The AI will get a positive feedback for doing the right things and negative feedback for doing the wrong things, so that it can accumulate the experience during the training and learn to achieve certain tasks. And the tasks we set for the AI is to operate the VPP system to achieve maximum benefits through participating energy market, demand response, frequency control, and also provide the load shifting. And we have trained the AI for over 40,000 episodes, and the training results are shown right now. And this is a very time-consuming process, but luckily we get some very good results to continue our simulation of VPP in all the communities. And shown on this slide is the data analysis result of the reduced electricity price for the 235 communities. This is the histogram plot. The x-axis is the price range, and the y-axis is the number of communities. So we found that VPP has good performance in lowering the electricity costs compared to the Victorian's average price. And with an increase in solar and battery capacity, electricity price can be even lower. And in terms of the environmental impact, we also find that VPP has good performance in reducing carbon emission, and the benefit will also be further improved with increasing renewable resources. So to further assess the VPP's performance among different communities, we also create the geospatial overlaying of the simulation result and map layer. So shown here is the PV coverage level of different communities. We found that the communities with higher socioeconomic advantages tend to have better access to rooftop solar, while those communities with less advantages shows the difference. And we also evaluate the 25 years project net present value for investing VPP. So with the geospatial analysis and simulation like this, we also managed to identify those communities that are suitable for deploying VPP, and those communities need further incentives and support from government or the future investment. So to sum up our findings, this research found that VPP has great capability in reducing electricity costs and also carbon emissions for communities. It also has a generally lower cost for electricity generation compared to the fossil fuel generator, but it's also more stable compared to distributed renewable energy. The existing challenge for VPP is that the renewable energy transition process requires technical and financial capability, and also the community support and awareness. But with the rapid renewable energy uptake and growing demand, VPP is of great potential in the near future. Outcome of this research is being utilized by the City Council of Greater Bendigo to advise the community renewable transition strategies and advocate the local investment. We are also joining more interest from other city councils in Victoria, looking to expand the coverage of this research. And an industry partner in Bendigo has sponsored a follow-up project for us to conduct further research in community-based renewable energy management system. And we have also managed to generate several publications and industry reports. Also, to share our research with broader audience, we created a web application where the user can interact and play with our research tools and the data. So if you are interested and want to know more about our research, just visit this site or simply scan the QR code on screen right now. Thank you all. That's all my presentation. I'm happy to answer any questions you have.
And thank you so much, Chengyang. 7 minutes and 40 seconds. I really appreciate it. If you can leave a QR code. Great. Just a quick clarification. So all of this presented was this your work, or was this part of a larger team at RMIT?
Sorry, what was the question?
Was this all the work presented, was this part of a larger team work, or was this was all of yours?
This is my PhD thesis.
Okay, outstanding.
But it is funded by some research partner, including the City Council,
sure,
and also the Civil Knight Center for New Energy Technologies.
Thank you so much. We're going to go on to our last presenter. Navo, are you ready? And yes, we are seeing your screen being shared. We do. Thank you so much. And you can begin when you are ready.
Okay.
Thank you.
Thank you. Okay, hello everyone, I'm Navo. And my PhD project was about developing an accurate methodology to estimate embodied carbon in construction supply chains using blockchain. I'm quite thankful to my supervisors, Professor Rina Ferreira, Associate Professor Sefani Senaratna, and Associate Professor Sean Jane for the great mentorship that I received throughout the entire PhD journey. And also I wish to thank my data providers, Landcom and ClearState, as well as other industry experts who contributed to my project in numerous ways. So carbon can be divided into two types, embodied carbon and operational carbon. If we look at a typical project, the operational carbon component is usually higher than the embodied carbon component. The latest trend is to come up with zero carbon projects where the operational carbon component is reduced to 0%. And as a result, the remaining embodied carbon component becomes almost 100%. So it was required to focus on this embodied carbon component and reducing that. When we talk about reducing embodied carbon, we need to know how much of embodied carbon is actually emitted. That brings embodied carbon estimating to the picture. At the moment, there are various databases and tools that you can use to estimate embodied carbon. But if we ask two people to estimate embodied carbon of a particular project, they would probably come up with completely two different answers due to various reasons. Differences in the system boundaries, differences in the databases, due to not having a consistent or standard method to estimate carbon. So it brought us this research problem where we wanted to develop a more accurate and consistent methodology to estimate embodied carbon. So for that, in my project, I'm using three concepts: supply chain, value chain concept, and blockchain technology. So in order to explain how I use these concepts, I will use a simple example related to installation of drainage pipes. So as shown in this slide, as you can see, initially you have to manufacture human pipes, then you have to transport these to the site. Then at the site, there are several activities that take place. So during each of these activities, a particular value is added. And in the same way, a particular amount of embodied carbon is also emitted during each of these activities. So in the same way that you can estimate the cost, you can add these embodied carbon emissions to estimate the embodied carbon. And I'm doing that using the technology blockchain. So blockchain is a decentralized distributed ledger technology that you can use to store record in a peer-to-peer network. Blockchain was initially used to record cryptocurrency transactions. in my project, I'm looking at using blockchain to record embodied carbon transactions. So with that, I moved to the aim of my project, which was to develop a methodology to estimate embodied carbon in construction supply chains using value chain and blockchain. To achieve this aim, I've established 5 objectives. I'll explain these along with my research methodology diagram. So the first objective was to understand the key concepts related to my study. For that, I conducted a literature review followed by a preliminary study where I used an embodied carbon database to estimate carbon for a particular project and identify the issues existing with these current databases and tools. The second objective was to develop a conceptual method to estimate embodied carbon using construction supply chain. So the developed conceptual model is shown in this slide. I've called it SCHEME, Supply Chain Based Embodied Carbon Estimating Method. So this method combines the value chain concept as well as blockchain. Then the third objective was to estimate embodied carbon using the developed method and compare the results with existing databases and tools. For that, I used several carbon data sets of 2 case studies and estimated embodied carbon using SCHEME, my method, as well as afterwards, I compared my results with existing database black book and tool eTool LCD. And the results are shown in this slide. So what I've realized in most of the cases, SCHEME provided less embodied carbon values compared to other databases and tools. The fourth objective was to develop a blockchain-based system to estimate embodied carbon. For that, first of all, I conducted a data modeling stage, which consisted of development of data flow diagrams and interrelationship diagrams. These were reviewed through a Delphi-based expert forum. Afterwards, I conducted a blockchain test rig in order to select a suitable blockchain platform to develop my blockchain-based prototype system. So at the end, we selected Hyperledger Fabric, which is an open source consortium type blockchain platform to develop my prototype system. So this particular slide shows you the data flow diagrams that I developed for the same example that I showed you previously related to installation of drainage pipes. Then these are the entity relationship diagrams that I developed for my blockchain-based prototype system. So these helped in developing this BEC estimator, my blockchain-based embodied carbon. BEC stands for blockchain-based embodied carbon, and I've called it BEC estimator. So this is the graphical user interface you would see of my system. And all embodied carbon contributors are expected to input their coal data, electricity data into this system. And the system will produce the embodied carbon estimates afterwards. So you can basically use this system to identify the low or high or carbon intensive materials, as well as low and high carbon embodied carbon contributors in the construction industry. Also, you can use this to benchmark the data as and when required. So I've used this, I've developed this using Hyperledger Fabric. Then the fifth objective was to test and validate the methodology as well as the developed blockchain-based system. So in order to do the testing, I used the same case study data set and calculated the embodied carbon values using my blockchain-based system. Then I compared those results with the manual calculations that I did in the previous stage, and the results revealed that they were the same. So it proved that my blockchain-based system also produces accurate and consistent results, and the functions and the algorithms were working fine. Then afterwards, I validated my blockchain-based system using another expert forum. So through the expert forum, I developed a SWOT analysis. So these are the strengths, weaknesses, opportunities, and threats of the BEC estimator that I developed, or the blockchain-based system that I developed. And the key contributions to knowledge of my study were a trustworthy and accurate methodology for estimating embodied carbon in construction supply chains, comprehensive data models to estimate embodied carbon, as well as a blockchain-based prototype system that you can estimate accurately and consistently. These are some of the awards that I received for my PhD project. And these are the publications that have come out of my PhD research. So in total, I have 12 publications, out of which 5 are journal papers, 4 conference papers, 2 book chapters, and 1 other publication. So these are the references related to the project. And with that, I would conclude my presentation. Thank you for your time. And I wish to thank CIB for this great opportunity to present my research as well.
Navo, thank you so much again. About 7.5 minutes. I really want to commend all three presenters for keeping to such great time. I know that's really, really difficult, and I know that you've prepared, and I really want to thank you for that. That's really important, I think, in our professional academic lives, is to be aware of the time and the time that we have, and I think you all did an absolutely great job. And what excellent research! I'm really excited about your research and your research futures. And Lee, I'm sorry, there was one quick question for you. In terms of the prototype, I'm sorry, for Navo, in terms of the prototype tool, compared to other tools to measure embodied carbon, could you just review for us what is unique about your particular tool quickly?
Yes. So the thing is, there's no standard way of estimating embodied carbon. That's like the key issue that you have. And when you use a particular tool, you rely on assumptions, you rely on various things. But when it comes to the system that I have introduced, it actually captures as and when the embodied carbon emissions occur. You have to just enter the fuel quantities or electricity that is used, which gives you a more accurate and consistent embodied carbon estimate. That's like the key difference.
Thank you so much. Thank you so much. I'm going to ask, our CEO, Don Ward, is here. I really thank him for attending this event. He has a busy schedule. I know he's traveling right now, and he's with one of our board members, Taha Elhag. So thank you for coming in, Don. And Don, you're going to lead just a little discussion with the three awardees and the audience, while I go to the breakout rooms with our four judges. Is that okay, Don?
Yeah, thanks, Mike.
Yeah, thank you so much. And so I'll be back hopefully in about 10 minutes. I think I'm doing this correctly, folks.
Let's just give Mike a chance to sort out the tech and take the judges to the other room. So I'm here with Taha Elhag, a board member of CIB. We've just been to see Dubai Municipality. Yes, Ron Wakefield. We're close to Qatar, but unfortunately not able to get over there to watch the England performance last night, magnificent as it was. I'm very happy if anybody wants to indicate in the chat if they have a particular question for our finalists, that would be great. But I'd like to ask all three of you really what you see as your motivation for carrying out the work that you have done, and where you see the impact of your work in the future. Let's go in the order in which you presented.
Hi, John. Yes.
Hi.
So due to the time limit, I couldn't talk much about the reason I select the topic. So we all know that the school building play important role in any development of any community. So both staff and students spend, most of their daytime inside the school building. So it's really important to keep the school building in a good condition. And yes, and we
then there's no dynamic way of capturing the data differences and all sorts of issues. So I've realized that there was a need to come up with a more accurate and consistent methodology where you can produce consistent embodied carbon estimate. So then why blockchain? Of course, blockchain was because compared to a traditional system, it has so many advantages. That's the reason why we looked at using blockchain, and we could store confidential data in a permission blockchain to avoid sharing of confidential data, and to make sure that it doesn't have the disadvantages of a traditional information system, basically with security, trust, decentralization, having the database stored in several locations, making it a more secure platform. That sort of, those are the main reasons why we selected this particular topic.
Thank you very much. Mike, I see you're back. Does that mean the judges have finished, or shall we carry on chatting?
No, please carry on chatting. I didn't want to interfere with them.
Certainly, no problem at all. If I just might comment on those three answers, thank you. You know, a modern way of describing CIB's vision is that we seek to maximise the contribution that research and innovation can make towards the attainment of the Sustainable Development Goals. And it strikes me with the contribution to improved education, better school buildings, and of course the impact on emissions and energy consumption that described between them by the three, that we've got three very great examples here of how indeed research does and will contribute to sustainable development goals. My colleague here, as I mentioned, board member Taha El-Hag, he has a question.
Thank you very much. Very interesting issues you are tackling here, and congratulations for your nomination for the awards. High quality work. Every research or PhD we undertake, there will be some challenges. Some of them will be under our control and we can work around them. Some of them will be outside our control. So if each one of you can pick up the key challenge which you faced and how you managed to deal with it. Thank you.
Let's go in the same order. If you heard that question, okay?
Yes. So thank you for the great question. I think the most challenge for implementation my framework in the practice is the resistance to change of people who involved in the process. Because in my framework, I introduce, like 3 more steps with more than 20 activities to help to solve the current issue, including like to create a shared vision, to collect the data at school level, or to upskill people who involved in process, or to add the performance evaluation. So for my evaluation phase, I have some comment from the school principal that they concern that people who involved in the process, might be resistant to change the current model. And that's why I create a table that you can see in my presentation with the, the challenge, the action for improvement, and the risk associated with each activity. And in my model, people don't need to add all activity at once. They can select each activity based on their current situation, based on the challenge they are facing with. And then, they prioritize and add more activity in the future that can help them to have less resistance to change of the people who involved in the process. Thank you.
Yeah.
I'll go first. Thank you for the great question and hard question at the same time, John. I think the most important thing to the community that our research can bring up is the impact to the both discipline and to the practice. So I can see clearly in our presentation, we highlighted the contribution to the literature review, to the body of knowledge, and at the same time, the contribution, the impact to the practice in the field. So for my own research, it's really important that the school principal, they see the framework is useful for their daily maintenance of the school building. And further, I can add the further development, the future research can bring the framework to the Ministry of Education if they can help to implement some or add change to some of the policy in the future that can help them to achieve the 6th objective in well-managed school property by 2030. It would be great. Yeah.
And I think, just to add, I think your work is really important in terms of for students and the quality of learning. So that's why I sent you that list to my colleagues who are researching in this area. We should get together. I think there's a whole body of knowledge around built environment and improving student learning by the quality of their built environment. So thank you for your work.
So much. Yes, thank you so much. Wow, noted the name here. Yeah.
Thank you, Ron, for the question. So I think, firstly, for the community's benefit, during my research, we have done a lot of mappings into spatial analysis, which created some new data set for the local communities that can help them with the decision making, renewable energy management, and the future direction of the renewable transition. And probably we also created a web application for knowledge sharing that can support the awareness of the importance in renewable energy and also the energy management system. And for the industry, probably for the built environment as a knowledge body, because during our literature review, we rarely found any previous study that can integrate the whole workflow or whole conceptual framework between the urban environment or built environment and the renewable energy management system or virtual power plant. So we create this framework to address those urban sustainability issues with virtual power plant. I think that's one of the major impact we have for the knowledge body and also.
No comment from me. I'm biased, apparently.
All right.
According to Don.
Yeah, thank you, Don, for your question. So, well, in my project, the key contributions were the accurate methodology, as I mentioned. Of course, the methodology that I'm introducing is a first principle-based methodology. So you don't need databases or a particular tool. You just only need the inputs that you need are the fuel quantities or the electricity usage for a particular activity. And then the system just estimates the embodied carbon pretty easily. And the other one is the fact that blockchain can be used for the applications, because this is like, nobody knows that blockchain can be used other than for cryptocurrency transactions and all that. So that is the key advantage of my project, bringing that forward, so that the others are aware of the users of blockchain overall as well.
Yeah, it's great work, Navo, and we need to link you up with Rebecca. She's also doing blockchain work. That would be really, really good to work across the Australian system. So congratulations.
And thank you to our three finalists for a great discussion there. Thank you. Really, really good to hear those thoughts from you. And now back to our Master of Ceremonies, Mike Bean.
Thank you, Don. Thank you for filling in and leading a great discussion from the audience. I was flipping back and forth. And yeah, I know the judges had a difficult decision from what I heard, chit-chatting and debating. Three outstanding, obviously, representing your individual universities is a really big deal, and all should be congratulated. All of our applicants should be congratulated for that, and our top three to be selected here. Kudos to everybody. Just I think the future's bright, Don. The future's bright for CIB and the student chapters, our early career research network. Just really exciting. And so the drum roll, please, if there's a drum roll. We the 2022 CIB Best Doctoral Research Award winner is from Massey University, Navo. Congratulations, Navo. And I'm going to turn it over to Billy Hare, who's going to give about a minute overview and some comments from the judge's perspective, which was again, as Billy will tell you, pretty difficult job we put these judges in. So thank you for their service.
Yeah, thanks, Mike. The only thing more difficult is Billy Hare speaking for 1 minute or less. All three, just to reiterate, Mike, all three were excellent. I'm not lying when I say I'll be sending these 3 PhD theses to my own PhD students to let them see them, and also to have a discussion about what a good PhD thesis looks like on all three. The three theses were all very well written, very easy to read, easy to understand. Anne Lee, your thesis was an excellent introduction if you haven't already understood the complexities of asset management around educational buildings and the impact of those, and the findings were obviously of national importance, we would say. Gavin's, an extraordinary amount of work, excellent use of flowcharts and visual aids to demonstrate some very complex issues, and we really appreciated that the subject matter is of vast importance, and if I can convince some guys in my department to maybe try and convince you to come to the Northern Hemisphere, I think there would be a job for you.
Billy, stop that.
Sorry, Ron. Sorry. And finally, Navo, your thesis was just outstanding from start to finish. I personally commented on just how state of the art your critique of blockchain research and technology. It's on its own is a seminal paper on its own. I think the outputs and a working prototype model, and its uniqueness, and it's so current and so relevant to on a global scale. So the marking criteria kind of led us towards your thesis. So if I can blame the marking scale, that's what put the other two behind you, Navo, but they're all so highly commendable. If that was under a minute, then well done.
Thank you.
Nowhere near a minute. I think that was 2 minutes, Billy.
It's great to see that Billy's trying to poach talent away from
come on.
Navo.
Can I just do a quick correction? I mean, I'm from Western Sydney University, not Massey University. Just wanted to.
Navo, Navo, could perhaps you could say a few words, and then we'll kind of open it up to the audience.
Yeah, sure. Thank you so much for the opportunity. I mean, presenting my research to an international audience is itself a win. I mean, that's how I took this, because presenting to a lovely audience and CIB, of course, has been helpful. I've been involved with the CIB student chapter activities at the Western Sydney University, so it has always been quite glad to be a part of CIB, and this was indeed a great opportunity to present. And thank you so much for the award. It just means so much to me, because it just gives the credibility for the project. And this might be probably the last time that I'm presenting my PhD project, because I graduated very recently. So, and good to finish my PhD journey with this award. So I'm very thankful to all of you. And I wish to congratulate the other two as well, because they are also winners, of course.
Thank you so much. Thank you to everyone. Thank you for everyone to participating. We are at the hour. But again, you know, I'm starting my day, so it's I could stay here all day and talk with you about this research if you want. We'll stay as long as folk likes, but this really ends our formal hour. We want to thank the audience for participating. Again, the judges who had a really difficult job. We thank them for their service. They continue to serve CIB. Thank you and congratulations to our 3 doctoral award winners. I know Don will be following up with each of you individually over the next couple of months. I'll be following up with you as well. So thank you so much. I hope everyone has a wonderful day.
Thank you, Michael. Echo your thanks to the judges. This award is taken very seriously by CIB. It's great to see last year's winner, Ismail, here as one of the judges. It's a prestigious award. At least 6 of our board members were here to hear these presentations, which shows you how seriously we take this. So congratulations from the whole board of CIB to all 3 finalists. And Billy, a particular thanks to you as the spokesperson for the judges, because I love the next task you've set yourself to take these all 3 dissertations to facilitate a discussion with your own students. What a great way of using you know, an event like this. I'm delighted that it adds value for everybody involved in that way. So yeah, thank you from me as well. Bye everybody.
Thanks.